Good morning. Here's a video for you on how to solve a system of equations. Now, there's a few different ways to solve a system of equations. So let's talk about those first. First of all, we have graphing. And all that would mean that we'd have an equation of a line. Let's say it looks like this. We have another line which looks like that. And so the solution of the system is the point of intersection. Okay, and so the point of intersection is the solution. All right, so that's probably the least favorite way to do these. The next way is called substitution. And this is what we've been looking at most in this class for the last week or so. Basically, all that means is you've got two equations. Let's say we have y is equal to 3x plus 4. And then we also have y is equal to 2x minus 8. Now, to graph those, that's not that difficult of a graph. We go, I'm going to do it in red so you guys can see a little bit better. But 1, 2, 3, 4, and we go up 3 over 1. 1, 2, 3 over 1. So there's the first line. And the next one, 2x minus 8, we go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And we go up 2 over 1. Right there. So this point of intersection looks like it's going to be way down here somewhere if I would continue it on. Okay, so not quite where, but not quite sure where that point of intersection is, but it's going to be way down there somewhere. That gives you an idea. So that's solving by graphing, but by substitution, since both things are equal to y, we can just substitute this in for y over here. So now we have 2x minus 8 is equal to 3x plus 4. And now we're going to solve for x. And when we do that, we subtract 2x from both sides. We have negative 8 is equal to x plus 4. And we have x then is equal to negative 12. Subtracting 4. So if you remember, we're going to get a point of intersection as our solution. Well, we've already solved for x. That's negative 12. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be way down here somewhere. 12 units over. Okay? And once we know what x is, we take that value and we put it back into either one of the equations. Let's say the first one. So we have y is equal to 3 times negative 12 plus 4. So y is equal to negative 36, yuck, plus 4, and that is negative 32. And so our solution set, ordered pair, is negative 12. If I were to graph this as accurately as possible, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It would be way 12, and then all the way down to, what, 32? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, it's going to be way down here if we graphed it. If it was a straight line, we were using straight edges. So anyways, that's the substitution method. So it's actually fairly simple. It's just a matter of substituting the value of one equation in for y into the other equation. Let's do another example. Let's say that I have y is equal to 2x minus 4, and then we have y is equal to negative 1/2 x plus 2. Okay. Now, again, if we're going to do this graphically, what would that look like over here? Well, that one's not a difficult one. So 1, 2, 3, 4. There's the y-intercept, and we go slope of positive 2 up 2 over 1, up 2 over 1. And so there's that line. I just have it dotted right there, kind of small. And then this one, positive 2. So 1, 2. And now we go slope of negative 1, which means down 1 over 2. Down 1 over 2. So there we can see the point of intersection, but it looks like we're going to get some kind of ugly looking fraction as our result. Well, let's go ahead and do it the same way we did before. We're going to take this and substitute it in for y. Doesn't matter. Doesn't matter if I go here to there or this to there. No, it doesn't matter. Doesn't matter at all. So we have 2x minus 4 is equal to negative 1/2 x plus 2. Now it's just algebra solving for x. We're going to get x's on the same side, so I'm going to add x, or half x. So I have 2x plus 1/2 x minus 4 is equal to 2. What's 2 plus 1/2? Just 2 1/2. 5 halves. Minus 4 is equal to 2. Now I'm going to add 4 to both sides. And so I have 5 halves x. Am I still on the screen? Yeah. Is equal to 6. To undo what they're doing, they're multiplying by 5 halves. So I'm going to multiply by 2/5. Whatever I do to one side of the equation, I have to do to the other side. So I have an ugly looking number, which is 12/5. So my solution set x value is 12/5, or 2 and 2.4, 2 2/5, but it's 12/5. All right, now how do we solve? Well, we take that and we put it in, and we're trying to simplify this as much as possible. So let me do that over here. Y is equal to 2 times 12/5 minus 4. Okay. Well, 2 times 12 is 24, so that's 24/5 minus 4. You guys remember how to simplify subtracting fractions? You got to get a common denominator. And so 24/5, multiply that by 5, is 20/5. Remember that still equals 4. 24 minus 20 is 4, and so we end up with just 4/5. Remember, we said that was going to be an ugly looking fraction. And that's right, 12/5 across, which is 2.4, and then up, not even 1. Pretty accurate, actually, the graphics. Okay, don't get lost in the fractions of all that, but just make sure you know how to do the substitution part of a system of equations. Okay. All right. Well, that's it for now, and we'll give you an assignment on Canvas. Okay. Hope you guys are doing well during this virtual week, and we'll see you soon.